Example number 5. Radioactive tracer problem. The compound 18-fluorodeoxyglucose, or 18-FDG, is composed of radioactive fluorine, or 18F, and as sugar, deoxyglucose. It is used to trace glucose metabolism in the heart. 18F has a half-life of about 2 hours, which means that at the end of each 2-hour time period, only half of the 18F that was there at the beginning of the time period remains. Suppose a dose of 18-FDG was injected into a patient, and let f of x be the number of microcuries, so MCI, or microcuries, of 18-FDG that remain over time x in hours as shown in this table. So we have a table presented at the right. This is our table. So letter A, find the number of microcuries that remain after 12 hours. Letter B, identify the pattern these data points follow. What type of function shows this pattern? Letter C, why can't you use the pattern to find f of 25? Letter D, find a particular equation for f of x. Make a plot to show that all of the f of x values in the table satisfy the equation. And letter E, use the equation to calculate f of 25 and interpret the answer. Okay, so let's begin by taking this table to the next slide. We have, of course, this is our x values. And these are our f of x values. Okay, we have first x value is 2, 4, and our x is in hours, 6, 8, 10, 12, etc., etc. So our x is in hours. And our f of x is in microcuries, so micro CI. Okay? So if our x is 2, we have 5. And then every 2 hours, the amount of microcuries are decreasing. So the initial amount is 5. It is decreasing after 2 hours by half of the original amount. So in 2 hours again, this will become 1.25. This will become 0.625, and so on and so forth. And we are asked to find the number of microcuries that remain after 12 hours. So let us investigate the pattern. First and foremost, we could actually visually, explicitly identify that this one, the x values are having an add property. So 2 is added to another 2, that makes it 4, and 4 added to another 2, that makes it 6. This one becomes 8. This one becomes 10. This one becomes 12. Now on the other hand, 5, 2.5, this is actually half-life. So meaning that your 5 going to 2.5 is multiplied by 0.5 or 1/2. So this is multiplied by 1/2 times 1/2 times 1/2. Therefore, on the succeeding cell, empty cells, then we also have to multiply the values of the previous f of x by 1/2. Okay. Let's be very careful with erasing this one. Okay. So what will happen with this? Okay. If our x is 8, it becomes 0.625 for our f of x. So the remaining is 0.625 microcuries. Because this has an add multiply property. This is basically an application of exponential functions, right? So for our 0.625 for f of x, if we multiply this by 1/2, let's take our calculator with us. So 0.625 multiplied by 0.5, that will give us 0.3125. So this will be 0.3125. In 10 hours, we will have 0.3125 microcuries. Okay, how about after another 2 hours? So this will be multiplied by 0.5 again. So this will be 0.15625. So 0.15625. Therefore, after 12 hours, so if x is 12, then f of 12 is equal to 0.15625 microcurie. Okay, so that is our answer for letter A. Letter B. Identify the pattern these data points follow. What type of functions shows this pattern? So as I've told you, this identify a, so let's indicate this is our letter A. This identify the add multiply pattern for exponential functions. Okay? Exponential functions. Letter C. Letter C, why can't you use the pattern to find f of 25? Now, as you can see, our pattern is add multiply, meaning that for every x on the left side of the table, we are actually adding 2 units from the previous to the corresponding x value, which is to the succeeding x value. So if we have, or if we extend our x up to the value containing the x is equal to 25, then definitely we are going to add, or we are going to reach up to 26. So that would give us, let's have a table here. Or we don't really need a table, just show that if we have x is equal to 12, then next to 12 will be 14, next to 14 would be 16, and 18, 20, 22, 24, and 26. Right? So therefore, for letter C, notice that our x is equal to 25 is trapped in between our 24 and 26. So we cannot use the pattern in solving for our f of 25 because it is not allowed on the add multiply pattern. See, it's here, it's 25. And we are so concerned with the add property on the x values, which is added, which is an addition of 2 from the corresponding x value to the succeeding x value. So we couldn't use obviously our f of, or our x is equal to 25 to find f of 25. Okay, therefore f of 25 cannot be found using this pattern. Okay, letter C, or letter D rather. Find a particular equation for f of x. Make a plot to show that all of the f of x values in the table satisfy the equation. So let's add another slide. And it says that we have to find an equation, the corresponding equation for this pattern. So notice that the add multiply pattern is exclusive for exponential functions. Am I correct? And let us label our values here for our x. This is in hours. Okay, this is in hours. And our f of x would be in micro curies. Okay, so we begin by, of course, setting the general equation or the general form of the power function, or the exponential, rather the exponential functions. So the general equation for the exponential functions is f of x is equal to abx, or y is equal to abx. So this is, so if our f of x is 5, so we are about to have the first 2 points, the 2 pairs of points. If our x is 2, then our y is 5, and if our x is 4, then we have 2.5. So we have 5 is equal to AB square. I need a clearer B. It's AB square. And then we have 2.5 is equal to AB 4. Okay. And applying the ratio in computing for A and B, then if we get the ratio of the first and second, this is our first and second equations. So we will have a ratio of 2.5 divided by 5. That would be equal to AB to the 4 over AB square. Therefore, we could cancel our A here. So that leaves us with 2.5 divided by 5. It's 0.5 is equal to B square. Right. And taking out the square of the B, we will have to raise the both to 1/2, or get the square root of both sides. So our B then would be equal to the square root of 0.5, and that would give us 0.70. Okay, let's have this one. So square root of 0.5. 0.5 square root, that's 0.707. So 0.707107. Let's take the first 6 decimals. Okay, now how do we get our A? To solve for A, we will have to choose any of the 2 equations given. So in my case, I want to choose equation 1. So this equation. So 5 is equal to AB square, and we know that our B is equal to a square root of 0.5. So 0.5 or 0.707. But I would prefer the original value, which is 0.5. Okay, square, and that gives me 5 is equal to A times 0.5, and A now will be equal to 5 divided by 0.5. So let's take out our calculator here. 5 divided by 0.5, which is equal to 10. So our A then is equal to 10. Okay, our equation now is, of course, equal to f of x is equal to abx, and our a is 10, our b is 0.707107 raised to x. This is our equation. Okay? Letter E. Use the equation to calculate f of 25. Oh, but wait, we are not yet done with letter D. Make a plot to show that all of the f of x values in the table satisfy the equation. So let us see. This is our equation. If our x is equal to 2, then let us have a computation for when x is equal to 2. So using your scientific calculator, we will have 2 times 0.707107 raised to 2. That gives us 5.0000. So this is confirmed. Okay, what if x is equal to 4? So let us just edit our x, and our x is equal to 4. Now we will have 2.5. So this is confirmed. If our x is equal to 6, then we will have, we just edit our x is equal to 4, make it x is equal to 6, and then we will have 1.25. If our x is equal to 8, so that gives us 8 for the x, and that gives us 0.625. So we are confirmed on f of x if x is equal to 8. What if it is 12? So x is 12, that gives us 0.15625. So we are actually correct on our f of x values. Okay, so we now go to letter E. Use the equation to calculate f of 25 and interpret the answer. Okay, but first we are going to plot the graph of the equation. So let's use the normal grids for every grid that you see here. That is equal to 1 unit for both of the x and y axis. Let's label our x and y axis. If x is equal to 2, then we have our y is equal to 5. So that gives us 2, 1, 2, 3, 4, 5. The point is here, 2, 5, 4, and 2.5. This is here. So 4, 1, 2, 3. So this is 2.5. 6 and 1.25. So 5, 6, 6 and 1.25 is here, and 8, 0.625, so 6, 7, 8, 0.625 is somewhere here. Okay, and then we just take this out, take the grids out, and now we are ready to form the graph of our exponential function. So we are just going to trace the curve by connecting all of the dots that you see. So it gives us a graph which is something like this. Now, in the real sense, this should be a perfectly smooth curve. Okay, so let's redo it. Okay, so this is, I think, better. And notice that this arrow here is extending to the positive infinity for x, but this arrow won't touch your x-axis until infinity because we have an asymptote. And remember, for exponential functions, the function won't contain the origin And also it will have an asymptote at y is equal to 0, or the x-axis. So this is our graph for this exponential function. So now we are ready to take on letter E. Use the equation to calculate f of 25. Interpret the answer. So letter E, f of 25 is equal to, and of course we are going to use the equation. Our equation is f of x is equal to 10 times 0.707107. Let's just limit it to 6 decimal places raised to x. If our x is 25, so that gives us f of x, or f of 25, okay, f of 25 is thus equal to 10 times 0.707107 raised to 25. And taking your scientific calculator with you, then that will give us, raise our x to 25, and that gives me my f of 25 in the calculator. It gives me 1.726348 times 10 to the negative 3. And of course that is equal to 0.0017263 microcurie. So this is the value of f of 25. And this means that after 25 hours, there is 0.0017 microcurie of 18 FDG left. So take note that from the original, our original is 2 hours, and we have 5 microcuries. And look that after 25 hours, then the remaining is just 0.0017 microcurie of 18 FDG. So therefore, if you have after around f of 26, we have of course less than that, and so on and so forth. So the amount of the 18 FDG is, it's getting less and less as hours pass by, and we get a half-life of it every 2 hours. So this is the answer for letter E. But let us go back to letter D. Letter D is asking for a particular equation for f of x. So a particular equation, meaning that there are other equations that could model the same type of problem. So depending on the kind of situation that we are dealing with, we can actually get another equation. For example, we have another equation which is g of x, let's say g of x, and let's equal to 10 times, this is still exponential of course, 0.707107 x plus sine of pi over 2x. So this is a sinusoidal function. This is a trigonometric function. And this function is actually modeled as, it will look like this. So from this point, it will travel to that point, and here it acts like a sinusoidal. So that is 10 times 0.707107 raised to x plus sine pi over 2x. So depending on the kind of situation that you are dealing with, then you can find another equation for the exponential function given by the pattern that you see, or that we are faced with, the given table. Okay, so that is how a certain equation fits a certain situation. So depending on the situation, we could model another function. So this is the complete solution for example number 5, radioactive tracer problem. And thank you for listening and watching, and have a nice day.